Hello students, in this video we will practice some questions on the topic Electrostatic Potential and Capacitance. This chapter is very important from exam point of view and has a huge weightage in exams. The following questions are for your practice and are in line with the competitive exam. So let's begin with question 1. A unit charge moves on an electropotential surface from point A to B. Then which of the following is correct? Before solving this question, let's draw an equipotential surface. So these are the lines, equipotential lines, and suppose there are 2 points A and B. So the potential at A is going to be VA, whereas potential at B is going to be VB. Now in equipotential surface, VA is equals to VB, hence it's shown in the figure. Hence, no work is actually required to move a unit charge from one point to another. That is, VA minus VB is equals to work done upon the unit charge. Correct? So, as the work done is 0, so VA minus VB equals 0. Correct? So, VA minus VB is nothing but 0. Let's move to question number 2. Question number 2 states 27 identical mercury drops, each charged to 10 volts, are allowed to form a bigger drop. The potential of the big drop is what? Now the voltage of each mercury drop is what? 10 volts. So it is KQ by R equals to 10 volts. So Q equals to 10 R up by K. So the total charge is going to be what? 27 into 10 R by K. Now equating the volumes to find the radius of the bigger charge, can I say that 4 by 3 pi R cube equals to 27 into 4 by 3 pi R cube, correct? So R is nothing but 3R, and the final voltage, can I write it as KQ by R, which is equals to K times 27 into 10R upon K times 3R, and this is equals to what? 90 volts. So 90 is going to be the answer. I hope you understood this. So let's move on to question number 3. Question number 3 states 1000 drops, each of V volts, are combined to form a bigger one. Then the ratio of potential of bigger drop to that of smaller drop is what? Now we know the potential of drop V is nothing but KQ by R, correct? So now the charge of the bigger drop, that is Q1, is going to be what? 1000 Q, okay? And charge, like the potential of the drop, as I told you, V is equals to what? KQ by R. So the radius of the bigger drop, that is R1, equals to 1000 1 by 3R by conservation of volume. So R1 equals to 10 times of R. So the potential of the drop V1 is going to be what? K Q1 by R1. And this is your R1. So V1 is going to be nothing but K times 1000 Q upon 10R. Correct? So V1 at the end is going to be what? 100 K Q by R. So V1 is nothing but 100 times V, because KQ by R is nothing but V, as I have written here. I hope you understood this question as well. So let's move on to question number 4. Question number 4 says the equipotential surfaces corresponding to a single positive charge are concentric spherical shells with the charge at its origin. The spacing between the surfaces for the same change in potential is equal to what? So let the equipotential surfaces have the potential of V1, V2 and V3 as it is shown. And obviously V1 is greater than V2 is greater than V3. Also, we know that V3 minus V2 will be equal to what? V2 minus V1, and this is going to be what? Suppose something that is R. So the potential of the charge is given by what? KQ by R. So V is equals to KQ by R, and R is going to be what? R is going to be KQ by V. So distance between the equipotential surfaces is going to be what? It's going to be KQ upon like into 1 upon V2 minus 1 by V3 and KQ 1 upon V1 minus 1 by V2. So when I'm going to solve, can I write that KQ, it is V3 minus V2 upon V2 V3, correct? Correct. And here I can write that KQ is nothing but V2 minus V1 upon V1 V2. So now I can write V3 minus V2 and V2 minus V1 as what? R, because these two are equal to what? R. So it's going to be KQR upon V2 V3 and KQR upon V1 and V2. Clearly we know that V2 and V1 are greater than V3 and V2. Thus, KQ R V3 by V2 is going to be what? Greater than KQ by R V1 by V2. Therefore, the spacing between the surface decreases as the potential increases. That is, R is going to decrease. So, what is the answer? That R is going to decrease. That is option number C. Let's move on to the last question. That is question number 5. Now, two conducting isolated spherical shells have a charge of positive 2 and positive 3. After closing the switch, select the correct alternative. So out of this, I need to select the correct alternative. Now, connecting the two spheres bring them at like a same potential. Now, since the spheres are isolated, let Q be the charge on the smaller one and capital Q on the larger one. So here the charge is Q and here the charge is what? Capital Q. Therefore, KQ by 10 will be equal to KQ by 20. That is equals to Q by Q, that is 1 by 2. Now, since the charge of the system is always conserved, can I write that Q plus Q is equal to 5? That is, Q is equals to 5 by 3 and Q is equals to nothing but 10 by 3. Now, charge on the larger sphere increases, that is, the electron move from the larger sphere to the smaller one. Also, the potential energy of the system is least in this charge distribution. So, the options which are correct are going to be A, B and C. That is, electron flows from the larger to the smaller sphere. The potential energy of the system is least after the rearrangement. And the final charge on the larger one is double than that on the smaller sphere after the connection is done. I hope you were able to digest all of it. So try solving the test for this chapter on EduRev and check whether you were able to score full or not with obviously complete understanding. Thank you very much.